Thanks, Tom, and thank you, everyone. In particular, thanks everyone for having me here. I'm having really a great time in Oxford. So what I'm going to present here is a draft paper. So it's very much a work in progress on the topic of mental privacy and the ethics of mind reading, reloaded, being it. It's very Zoom. Okay. Yeah, so it's really a work in progress. So feel free to provide any charitable or uncharitable feedback. That's very much welcome. So it was not switch to the original cursor here. No, there it doesn't work, and the cursor is disappearing. Oh, here it is. Okay, it's probably yeah. All right. So I'll start with two quotes. The first one is by Paracelsus, Renaissance physician and natural philosopher, who wrote, "Thoughts are free and subject to no rule. On them rests the freedom of man." And the second quote is a bit more recent, so 4 centuries later, historian John Bagnall-Bury, the author of a monumental history of freedom of thought, started this book by saying that it is a common saying that thought is free and man can never be hindered from thinking whatever he chooses so long as he conceals what he thinks. And these two quotes, I think, kind of provide the framework for the presentation that I'm going to give, because in this paper, I have 2 main objectives. One is to scrutinize the technological and conceptual premises of mind reading. And the normative part is trying to make an argument that privacy of mental information should be considered a fundamental right. So when it comes to mind reading, many bioethicists and neuroethicists perceive this as a kind of outdated debate, which was very popular in the 1990s and at the beginning of this century, following recent developments in functional magnetic resonance imaging technology. This is what we could refer to today as the classic mind reading debate. So for those who don't know fMRI, it's a technique to measure brain activity indirectly, namely by detecting changes associated with blood flow. So when a certain brain region is in use, so there is an increased neuronal activation, then blood flow to that region also increases. So by detecting this increase or decrease in blood flow, we can also make indirect inferences about neuronal activation in that particular area. And a lot of neuroscientists a few decades ago were very excited about the possibility of using functional magnetic resonance imaging to infer mental states. This is a quote by John Dylan Hines, one famous cognitive neuroscientist, who wrote in the mind reading entry of the Oxford Handbook of Neuroethics that by combining fMRI with pattern recognition, we can, it is possible to read out very detailed contents of a person's thoughts, including detailed visual percepts, ideas, memories, and even intentions and emotions. And it is possible to read both implicit and even unconscious mental states, such as unconscious percepts and decisions. So this kind of very enthusiastic claims became controversial a few years ago for a variety of reasons. One reason was that fMRI studies had a hard time being replicated. So a lot of meta-analysis in the subsequent decade showed that many fMRI studies failed to report their analysis pathways in their publications and making an exact replication of those studies nearly impossible. And following this, a lot of people started talking about the replication crisis in fMRI-based neuroscience. And then there was also a conceptual problem with such enthusiastic claims by Heinz and colleagues. This is well put by Marta Farah, who argued that due to interpersonal variability, fMRI can demonstrate correlations between brain activity and behavior on a group level, but its ability to identify a single mental state in one person may never meet a tolerable level of accuracy. So to use sort of life cycle of scientific claims, such as the Gardner's hype cycle, we could probably argue that the end of the last century, the beginning of this early century, was a sort of peak of inflated expectations regarding mind reading. Then we went through what we can call the disillusionment phase. But I would argue that now we are moving up again towards what we can call a plateau of productivity in neuroscience. And in a second, I will explain why. But problematic conceptual premises of the classic definitions of mind reading, I think a very valuable account is provided by Dan Dennett and Marcello in their early 1990s work on mental representations, as they distinguish what they call representings from representeds of mental representations, also called the distinction between the vehicle of a mental state and the content of a mental state. And Dennett and Ginsburg argued, and I think this is still valid with today fMRI studies, that what we can grasp from fMRI signals or other indirect or direct brain recordings is the vehicle of a mental state, but not the content of a mental state. To use an analogy, we can reveal something like a traffic road sign, but not the actual process of crossing the road on the zebra. So what has changed since then? Why the debate about mind reading that happened to be obsolete a few years ago is interesting again today for neuroscience, for computer science, and for ethics? I would argue there are two main socio-technical trends that are interesting here. The first one, we can call it AI decoding, and the other one, we could call it big data as applied to mental states or big mind data in absence of a better wording. So why is AI changing the science of inferring mental states from brain activity? Mainly because AI models, especially ANNs, artificial neural networks, are providing the algorithmic tools to enable a new type of inference. So classical inference in neuroscience, in imaging studies, was what has been called the forward inference. So you manipulate a specific psychological function in order to identify localized effects of that manipulation on brain activity. So say you manipulate attention and then you identify the localized effects that manipulating attention has on brain activity and which brain regions are involved. With AI-based models, what we can do is also what has been called by people like Russ Poldrack and others, reverse inference. So you sort of reverse engineer the process. So you can reason backwards from patterns of data, such as neuronal activity, but as we will see, it's not necessarily new brain data, it's not necessarily neuronal activation, to infer the engagement of specific mental processes. And this is a new thing, and it's quite exciting what new approaches to computational neuroscience can do. I think this is one of the most interesting cases. It's the work of Jack Gallant and his lab at University of California, Berkeley. I think they are probably the research group that worldwide is coming closer to inferring not only the vehicle of mental states, but also the content, to use Dennett's terminology. These are two studies that they published a few years away from each other. The first one is about reconstructing the visual content of mental states from brain activity. So basically, they presented participants with visual stimuli. In this case, was a video clip of a short movie, and then they train an artificial neural network to reconstruct the visual content of these mental states from using only brain activity. And as you can see, the level of detail is not grandiose, so you cannot determine, for example, the identity of the person involved. So you cannot use it, for evidential testimony in courts, but it's already quite advanced and sufficiently sophisticated to determine whether you are having a mental state related to a person as opposed to a known person, as opposed to an object, and even as opposed to a non-human animal. So I think this is already quite exciting. In this other study, what they were able to do was to infer the content, the semantic content of mental states. So the first study was about visual content. The other one is about semantic content. So they train using the same methodological approach. They train an artificial neural network to decode the semantic content of mental states for brain activity. So this map identifies with which concepts could be inferred from brain activity. The concepts in white are those that have a higher statistical accuracy, so those that could infer more reliably. The ones in blue or purple are the ones that could be inferred with less statistical accuracy. And if you go close, you could see that all large taxonomical concepts, so for example, being a human or even being a mammal, could be inferred quite reliably by the artificial neural network. The second socio-technical trend, which I think is revamping interest on mind reading, is what we can call big mind data. But as I said, if you have ideas about a better concept, this is very welcome. So big data approaches that basically involve data related to mental states. So we can call this a large scale, the availability of neural and non-neural data resources, which is enabling processing activities that are aimed at inferring mental information via reverse inference. Why am I saying neural and non-neural? Because this process of reverse inference can allow us to reconstruct mental states, not necessarily only from brain activity, but also from non-neural data, such as voice recordings, text, and so on. There are several trends in this field. One is consumer neurotechnology, which is basically neurotechnology used outside of the clinical setting or outside of the biomedical research setting as a personal technology. More and more people worldwide are using devices such as wearable neuro headsets, like these two that you see here. They're usually based on electroencephalography, so they collect electrical activity from the brain in a non-invasive manner. And this can be used for a variety of purposes, such as cognitive training, neurofeedback, and so on. Other technologies, such as digital phenotyping, can use a similar approach, but instead of collecting direct brain activity directly, they mine proxy informations. For example, approaches such as affective computing, also called emotion AI, can use face recognition technology to create aggregate statistical correlations between certain face expressions and certain mental states, with an increasing degree of accuracy. And social media platforms, as you all know, are attempting to do the same. So there are studies that, for example, use Instagram pictures as predictive biomarkers of mood disorders, such as depression. And the Cambridge Analytica scandal from 2018 was a very famous example of abusive data processing actors using social media data to infer mental states for purposes such as psychographic profiling, so clustering people according to their psychological traits. So based on these trends, we could probably argue that mind reading the problem of mind reading is more complex than we originally thought. And we can distinguish probably two different problems of mind reading, which borrowing the terminology from Noam Chomsky's theory of language, we could probably call mind reading in the narrow sense and mind reading in the broad sense. So mind reading in the narrow sense is the possibility that at some point we will be able to decode the content of mental states from brain recordings. And this is the classical problem of mind reading. And as we said, with studies like the ones by Jake Gallens that I mentioned before, we are slowly embarking on this project, but we are quite far from having like a rich and complete understanding of the content of mental states. But what we are already experiencing today and what is already relevant from an ethical perspective is the possibility of revealing privacy-sensitive statistical correlations between certain data aggregations, neural or non-neural data. I think we will need what the lab access that there is no battery. You're gonna
I have one upstairs.
Okay, let's see how long the laptop will survive, and certain mental states. So, and the second problem is already very relevant today. So these two problems can also be worded by distinguishing two types of privacy. So we're now shifting from the descriptive to the normative domain. We can distinguish two problems of privacy. The first one, we could label it as neuroprivacy, and the second one, mental privacy. So what's the difference? Let's try to frame this broadly. So privacy, as you all know, is conceptualized in many ways, but the most common and influential approach to conceptualizing privacy is the one provided by Warren and Brandeis at the end of the 19th century, who interpreted it as a right to be alone. And a lot of research in legal philosophy has tried to determine what the actual meaning of this act of being let alone. And one influential account is the one provided by Bock in the 1980s, according to which privacy is the condition of being protected from unwanted access by others, either physical access through personal information or attention. So, and when personal information is involved, so the second category in Bock's definition, then we have a subtype or subset of a subset of privacy, which is called information privacy. So the privacy of personal information. Now, where do neuroprivacy and mental privacy fit in this picture? There are two subtypes of information privacy, but they're not, these two subtypes have a significant area of overlap, but they're not supervenient entities. So it is possible to have mental privacy without neuroprivacy involved. It is possible to have neuroprivacy without mental privacy involved, and I will explain why. But so neuroprivacy can be defined as the protection of brain data, also called neural data, whereas mental privacy concerns the protection of mental information. Now, distinguishing these two categories, I think it's very important because data and information are not the same thing, even though these two terms are usually often used interchangeably in ordinary language. So brain data are the individual raw measurements of human brain structure, activity, or function that still need to be processed. Whereas mental information is the processed and organized set of data that collectively carry a logical meaning, so they have truth values and accurately reveal aspects of mental states such as thoughts, memories, and emotions. As I said earlier, these two sets are not supervenient, so that's why they are presented here in a Venn diagram. So not all neuroprivacy challenges have to do with mental information, and not all mental privacy challenges have to do with brain data. So to give you an example, there is plenty of parallel studies about neuroimaging biomarkers of neurological and neuropsychiatric conditions. Schizophrenia happens to be one of those conditions for which we have a quite large number of neuroimaging biomarker. But by decoding this biomarkers, we are not able to make any inference about the mental states of the people who have those biomarkers. So we definitely have a health privacy problem because you are revealing sensitive information about a person's health status, but you're not inferring anything related to mental states and to the content of mental states. On the other hand, it is possible to have mental privacy without neuroprivacy being invoked. This is the case, for example, of Emotion AI, where you use data sources such as natural language, or eye tracking, or facial expressions to detect and analyze affective mental states or emotions. So we can define neuroprivacy as the right and ability to exercise control over their brain data. And as such, this qualifies as a subset of medical privacy, which is the privacy of medical data. Now, brain data have specific features that make them particularly interesting from a privacy perspective. One is that they are predictive of present and future health status and behavior. So if you have access to, for example, my neurological measurements that show a predisposition to develop, say, early onset dementia, this is an information that can be quite problematic for me if it falls in the wrong hands, such as my health insurance provider or my employer. They have high temporal resolution, meaning that certain techniques such as electroencephalography can monitor brain activity real time, which is not common to all physiological measurements. And they are not in a read-only format. Brain data are always in a read and write format. So you can read brain information, but you can also write into the brain using techniques such as neurostimulation and neuromodulation. So potential risks for neuroprivacy include the collection of redundant data during brain recordings, which is particularly challenging when it occurs outside of the clinical setting, such as in neuromarketing studies. The repurposing and recontextualization of brain data, the collection of brain data on the weak consent regimes. This is a very big problem with consumer neurotechnology applications, which are used typically without medical supervision, and the only consent regime is basically accepting the device terms of use, just like any other software or hardware for personalized use. And then also the problem of malicious hacking of neurotechnology. So when someone hacks a device to extract information or to sabotage the function of the device, this will also fall under this category. Regulating neuroprivacy is quite a topical area now for neuroethics and neurolaw. Because of the inherent features of brain data that I've mentioned earlier, there are several approaches. So a lot of people are arguing that we should regulate brain data in order to enhance our bar of neuroprivacy. One approach that I found interesting and that I support to a large extent as being provided by Steve Rennie and Chris Bublitz, who argued that we should treat all brain data as health data. So basically expanding the category of brain data, and even when brain data are collected outside of the clinical setting, such as with direct-to-consumer applications, the data collected in this way should still be considered health data. Another approach, which is actually not necessarily in opposition to this, actually the two things can be harmonized, is treating brain data as a special category of health data. So all brain data are health data, but within health data, you can have multiple categories. As some of you probably already know, genetic data are considered a special category of health data under the General Data Protection Regulation of the EU. And so brain data could become a similar special category of brain data. Then there are also more radical approaches. So interestingly enough, the Chilean Senate has passed a neuroprotection bill, which regulates brain data in the same way as human organs, which is an interesting equation because it's the first time that data are regulated like tissue. So their approach is aimed at basically shutting down the entire market of consumer neurotechnology. So you can only donate your brain data voluntarily, but you cannot monetize that. It can only be an act of non-monetizable donation. The positive news here is that regulating neuroprivacy can benefit a lot from technological solutions. So techniques to ensure data security and privacy, such as homomorphic encryption, differential privacy, secure multi-party computation, and others are proving to be quite successful in achieving this goal. Now let's look at mental privacy, because here things get a little trickier. So mental privacy can be defined as the right and ability of people to exercise control over their mental information. And as such, it can be defined as a right to mental self-determination. And if we really look at the fundamental conceptual foundations of information privacy, we see that this cognitive dimensions of exercising control about information about ourselves was actually at the center of the legal philosophical discourse way before that neurotechnologies became widely available. This is a quote by Freud's Anatomy of Values. And I think there is, at least the argument that I try to make in this paper is that mental privacy is a fundamental prerequisite of information privacy, because only by exercising control over one's own information about their mental states, it is possible in principle to exercise control over any other form of information. The inherent features of mental information are different than the inherent features of brain data. But what is, I think, very relevant from an ethical perspective is that mental information includes not only observable behavior, but also unexecuted action and unspoken speech. The second feature is that mental information may elude conscious control. So a lot of brain imaging techniques operate below the threshold of conscious awareness of the person. So it's very hard for the data subject to determine for himself or herself which information should be secluded or not. And the same goes with NLP-based or other non-neural approaches. And then again, that this information is not in a read-only format, but can also be modified. Regulating mental privacy due to these inherent features is trickier because it's very unlikely that data type based approaches can be effective. So let's assume we regulate all brain data as health data. There's still a plethora of other data sources that can be used to make inferences about mental states. So this will not really solve the problem. So it seems that it is advisable to shift from a data-based approach to an inference-based approach. So the normative criterion here should not be the class of data that are used, but the kind of inferences that are derivable from a certain data category. So regardless of whether you're collecting voice recording or electroencephalography data or facial images, the important thing is the kind of inferences that your model draws. So if your model is making predictive inferences about mental states, it is at a higher risk of violating mental privacy and has to be regulated accordingly. So the question should be not which data will be processed, but how. Examples of mental privacy relevant cases, again, involve inferring emotions from face recognition, inferring mood from natural language processing, and inferring cognitive function from neurofeedback or cognitive training apps. So, concluding, why mental privacy? So based on these inherent features and this normative prerequisites can or should be considered a fundamental right. I want to state here the previous quote by Burri, namely, which highlights this intimate connection between mental privacy and freedom of thought. So people in Burri's account can exercise their freedom of thought only to the extent that they can conceal their thoughts, so that only to the extent that they can exercise their mental privacy. Another, I think, useful quote here is by Michael Lynch, who wrote a very important work on privacy and the threat to the self. And Lynch argued that the concept of privacy is intimately connected to what it is to be an autonomous person. And I find funny that he mentions this because he never makes examples related to neuroscience or AI. But in this book, he wrote that if I could telepathically read all your conscious and unconscious thoughts and feelings, then your existence as a distinct person would begin to shrink. And our relationship would be so loop-sided that there might cease to be, at least to me, anything subjective about you. So trying to translate this into a set of normative requirement, mental privacy could be construed as a fundamental right for 5 main reasons. The first one is that it is a prerequisite of information privacy to work. So only by exercising control over your mental states, you can exercise control over the information that you externalize from your mental states onto the world. It is constitutive of subjective experience. So mental information is the only piece of information that we process that is inherently subjective. It is a precondition for the development and preservation of personhood and personal autonomy, as Lynch argued, and it is a prerequisite of freedom of thought, because, of course, unauthorized access to mental information increases the risk of covert irrational influence or manipulation. So the higher the chances of violation of mental privacy, the higher the chances of violations of mental integrity. And finally, as Reinman and others have argued, mental privacy is necessary for the recognition of one's ownership of their physical and mental reality. I want to conclude with an open question, because this is something I do not have a fixed opinion about, so I would be really curious to know about your thoughts on this. So should mental privacy be considered a relative or an absolute right? As you know, most rights are relative, they're not absolute. Very few rights are absolute, like the right not to be tortured. They do not admit any exception. Paul Wolpe has actually argued that mental privacy should be an absolute right. So he argued that the skull should be designated as a domain of absolute privacy. No one should be able to probe an individual's mind against their will. We should not permit it with a court order. We should not permit it for military or national security purposes, and no coercive use should be accepted. An interesting alternative is provided by science fiction. In a 1990 episode of Star Trek, Captain Kirk is being informed that a dangerous spy has surreptitiously joined one of the groups that are visiting the Enterprise, and he desperately wants to identify the intruder and to know more about his plans. And he appeals to one of the staff members who happen to have telepathic abilities. And so Kirk wants to read the minds of all the visitors in order to understand which one is the dangerous type. However, the captain is reminded by one of his assistants that according to the law, the right to mental privacy is an inalienable right of all Federation citizens and shall not be abrogated. But they also mention a clause to not be abrogated without due process of law. So it seems that in court proceedings, exceptions to the absolute nature of mental privacy can be admitted. And this is something I think that is very pertinent to our current scenario, especially in neuro law. So should, for example, mental privacy violations be admitted under risks for national security, for public health risk, and so on. And I think this is an open question to which I don't have an answer yet. We can discuss the pros and cons of each approach, but I haven't balanced them yet. So thank you very much.